Comprehensions in Python are a concise syntax for describing lists, sets, or dictionaries in a declarative or functional style. This shorthand is readable and expressive, meaning that comprehensions are very effective at communicating intent to human readers. Some comprehensions almost read like natural language, making them nicely self-documenting. Let's start with list comprehensions. Comprehensions are much easier to demonstrate than they are to explain, so let's bring up a Python REPL. First, we'll create a list of words. Why? Sometimes I've believed as many as 6 impossible things before breakfast, by splitting a string. Now comes the list comprehension. The comprehension is enclosed in square brackets, just like a literal list, but instead of literal elements, it contains a fragment of declarative code which describes how to construct the elements of the list. Here, the new list is formed by binding word to each value in words in turn and evaluating len word to create a new value. The general form of list comprehensions is expression of item for item in iterable. That is, for each item in the iterable object on the right, we evaluate the expression on the left, which is almost always, but not necessarily, in terms of the item, and use that as the next element of this new list. This comprehension is the declarative equivalent of the following imperative code, which uses a for loop and a list to accumulate the lengths found so far. Notice that the source object over which we iterate doesn't need to be a list. It can be any iterable object, such as a tuple. The expression which is in terms of the item can be any Python expression. Here we find the number of decimal digits in each of the first 20 factorials using the range function to generate the source sequence. Note also that the type of object produced by list comprehensions is nothing more or less than a regular list.